first thing that I want to do is to thank Praveen, who spoke a lot of good things about open source security tools and why you should look at it. The reason being, I built an open source security tool in software composition analysis space. But this talk is not about how to use the tool, but it's more about sharing my learnings and insights in building this tool for over a year, looking at feature requests, which are basically GitHub issues, looking at bug reports, looking at people telling me that this doesn't work, and most importantly, talking to users, right? What is it that they are looking for? So someone asked that, why should I use open source tools, right? It is because many times the developers, us developers, are available to you to, to understand what is it that you need and build for you, right? So primarily this talk is going to be about my learnings. So yeah, this talk is going to be about my learnings, about the things that I have gathered while building this tool. I will also talk about two very interesting case studies on how a security team uses VET, the open source project that I built, for building policy-driven guardrails against open source risk. The second case study is going to be towards the engineering team, how this tool helps engineering team in certain use cases, right? And towards the end, the last slide is going to be about an opinionated approach on what I see is required in order to solve the problem of open source software supply chain risks, right? The expectation is that, or the intention of this is that as security leaders, many of you will discover that there is a problem with open source risk. They are very real, and over time it is increasing, right? So maybe you will see what to do about it. As well as for founders, you will probably discover that there are a very interesting problem in this space, which is a gap today. And maybe you would be interested in solving, right? So yeah, quickly to give an overview of VET. VET is a next-gen software composition analysis tool. It supports a wide variety of ecosystems such as Java, Node.js, TypeScript, JavaScript, Ruby, as well as Go. It supports some of the advanced features like code analysis. That's why I can call it next-gen and not just conventional SCA, right? I think among the open source SCA tool, VET is probably the only one, or maybe I think few more are there, which has this ability to parse through code and perform what is called reachability analysis, which is one of the hot topics last year, not so much this year because people figured out it's a very hard problem. Secondly, VET also goes beyond just vulnerabilities. Generally, we look at only vulnerabilities in libraries, but that's not the thing. If you really think about it, vulnerabilities are discovered mostly in popular libraries. No one looks at unpopular library. Imagine a single developer maintained library where no release has happened in 2 years. No commit has happened in many years. That is part of your product. That is a potential risk, right? So VET allows you to look at those attributes as well. But the most important thing of VET is really the policy as code. When I created VET, I had this own problem. Like I was working for ChargeBee and I had this same problem. My hypothesis was open source risk management is about data and policy problem, like most other security problems. If I can collect the most relevant data about open source libraries and usages in my code base and allow the users to write policy to describe what is risky and what is not risky for them, then it will be an effective tool. So that's why policy as code is like central to VET. It does not have an opinion of what is risky, what is not risky. It allows you to codify your opinion, and it just acts as an enforcer of opinion to achieve the goal of automating the process of vetting third-party open source libraries as part of CI/CD, right? Over time, as I kept on building VET, looking at feature requests as well as talking to people, focus of VET has also kind of shifted towards remediation. Because a lot of people have asked me that it finds all these risky libraries. Now what? Right? So not that VET solves it, or VET is not a remediation tool, but as developers, we have some focus on the remediation side as well.
Now, who uses VET? Okay, I've been saying that I build VET. Now, are there any user or is it just another project in GitHub? Now, VET do not collect any personally identifiable information or even any telemetry. It's an open source project, you can look into it. But we do host a backend API to aggregate data, security metadata about open source library. For example, VET detected 5 libraries used in your code. Now, in order to allow you to write policy or enforce policy, it needs security metadata. So we host a API which allows VET to pull that aggregated security metadata. So we have about 1.5 million API calls there. We don't know from where, but we see pretty good usage. Among the feature requests in GitHub issues, as well as more importantly, talking to the users, no surprise there, SBOM is the most popular topic. People ask that, do you scan SBOM? What should I do with SBOM? Can you generate SBOM? Where to store SBOM? A lot of questions. I don't really have answers, but yeah, that's a stat. Like a lot of ask on the SBOM side. Interestingly, last year when I started, I thought that code analysis, reachability analysis will be a very, very important feature, which I will eventually build in VET. It turned out not many people, at least the people who are using VET, not many people are talking about reachability analysis, right? Among the ecosystem, among the users of VET, the top 3 ecosystems are Node, Java, and Ruby. I think this kind of aligns with this Stack Overflow developer survey as well, except for Ruby. Okay, let me jump right into the case study. One of the interesting use cases that I have discovered while talking to some security engineers who use VET is that they want to achieve this centralized policy management owned by security team. They want to define the policy for open source risk, like what is allowed and what is not allowed. They want to define that as policy. They want automated enforcement of that policy. They don't want to go manually vet every single pull request which makes a library change. A very common place, like whenever engineering makes a change, like adds a new library or bumps up a version, a common thing is that someone from the security team will come review the pull request, manually check if the library being introduced is it maintained, does it have vulnerability. Enterprise tool like Black Duck and all of that does that, right? The goal was similar, but achieved with pure open source. So what this team did, they built something called a reusable GitHub workflow, using which they shipped VET's GitHub action and their custom policies. So they have a repository with their policies, which is defined in YAML. As a package does a GitHub reusable workflow, that gets plugged into the main CI/CD pipeline, which is another GitHub action managed by the DevOps team, right? So this way, the security team offered a service of building a guardrail against risky open source library, which goes into the main pipeline with full control on the policy. If the security team needs to do a policy change, all they need to do is update the YAML file and push into their repository, and it will percolate into the main CI/CD pipeline. So this primarily is possible because of GitHub's reusable action. But yeah, this is one of the interesting use cases that I have found teams using. Second, this was a particular use case or particular ask from the engineers. One of the problems is that as a developer, many a times we add libraries. Say we add library X. In reality, that library X also depends on other libraries. Those libraries in turn depend on other libraries. So if you add one library, there is a possibility you are introducing almost 100 libraries into your application. The entire thing is those are called transitive dependencies, like dependencies of dependencies. One problem that we faced initially is that security engineers would come and tell us, as well as engineers would come and tell us that VET found a risk in library Y. But I have not added library Y. Where is this library Y coming from? Right? Those were transitive dependencies. To help solve that, one of the features that we built was reconstructing the dependency graph. We don't just look at a list of dependency. Wet is able to analyze the source code as well as use its backend infrastructure, the data that comes from it, to build a full graph, a relation of libraries. And any risk found in any of these libraries can be traced back to a top level library, which is declared by the engineer. So this feature has been fairly popular among the users of Wet. So if you see this graph here, the red nodes identify libraries which violate some policy. But looking at the graph, you can easily trace back that transitive dependencies, how are they introduced, right? So if you're a security engineer, you can just quickly look into this graph and tell, update this library, one of the top level dependencies. Updating those libraries will fix a lot of this transitive dependencies, right? The goal was to reduce the time to fix. Okay. So finally, I want to talk about how does the open source software supply chain risk looks like and what is required in order to mitigate this risk. A lot of things in the slide. It's okay. I'll talk about it. Today, the biggest problem with open source libraries is this. Linux Foundation survey points out that almost 80% of modern software that we are shipping constitute of open source code. Say I'm building an application, an enterprise application, and finally the artifact that gets built, maybe a container image or a jar or some software artifact. Chances are that majority of it, almost 80% of it, is open source code coming through various libraries, right? Now imagine this. Even in large organization, we have our product security practices. That product security practice is for internally generated code, right? That means maybe only 20 to 30% of the final software that we are shipping. What about all the open source code that is coming into your application? If there is a vulnerability there, you are shipping that vulnerability. No one is going to say that it's because of open source. Like it's like the software artifact that we are shipping that is vulnerable, right? So far, all these years, we have only looked at vulnerable versions of libraries, right? If you really look at it, vulnerabilities are found only in popular libraries, not in everything else. In Spring Boot, there are if you add Spring Boot, 100 plus dependencies are added. Many of those libraries are actually single person project, unmaintained, right? So what about those? What stops an attacker from looking into one of those libraries, finding a flaw, right? SCA tools, even Wet, will not report that. This is the bigger risk of open source supply chain, software supply chain. How do you trust open source code at par with your product security practices, right? This is the fundamental problem. How does software consumers verify and trust software coming from the software producers, which is in this case the open source ecosystem, right? This problem is not solved because the open source ecosystem is huge. You have an engineering team who is building a library. That library has a vulnerability. You will go tell the engineering team, fix this vulnerability, man. Otherwise, all these products will get compromised. What happens with open source? You're using those libraries, right? Who will you tell? That library may be unmaintained. If your risk perception is high, maybe you'll have to invest engineering bandwidth in maintaining those libraries, right? So over time, it seems like that the open source software supply chain problem can be fixed by generating a lot of security metadata. It is expected that over time, open source project will also publish security related metadata like its SAST results, dependency scanning result, SBOM, signing, and bunch of things. It will not happen soon. It will happen over time. And the role of the consumers of the software is to verify those security metadata, establish trust that it is at par to your product security standard before you use it, right? This ideally should mitigate two of the largest problems which is there today, vulnerabilities. And vulnerabilities, I think all of you are aware of, malware. This is one of the biggest problem of open source today. Massive amount of malware sprawls. Like people are publishing malicious libraries which named similar to popular libraries. Open source maintainers getting compromised or turning rogue and releasing a new version with malicious code, like what happened with XZ incident. Yesterday, incidentally, I came across a blog post by JFrog people where they said that they discovered a GitHub pat, a secret in one of the container images, which gave access to the Python's PyPy infrastructure. Right? Imagine if some attacker would have got it before JFrog guys were able to help fix it. The attackers would have been able to publish malicious packages, right? So these problems are real. I think the problem of open source software supply chain is to figure out how to establish trust and safety for consumers of open source software. Yeah, thank you so much. If you have any question, I'm here. You can ask me now or during the rest of the day. Try out VET, and I'm happy to build feature which helps you to adopt VET as well.
You mentioned the dependency graph, right, of the libraries, all the supporting libraries that some of the projects are using. What happens when one of the versions changes, right? Like do you rebuild the entire? Do you rebuild the entire dependency graph for each version change of each of those components? I'm also more interested in the infra side of it. How do you store this information and run processes which kind of rebuild this, if you do that?
We don't have any infra other than serving security metadata of open source packages. We don't store any data because it's an open source, free and open source tool. The most common integration for people is adding it as part of GitHub Action or GitLab CI workflow so that it automates the process of vetting a pull request. And as you said, like when a version changes, yes, we recompute the dependency graph on the fly. If you integrate VET with GitHub Action, VET has the ability to identify only the differentials in the pull request. It will not scan everything and tell you like 500 issues. It can identify that in this pull request, only this version changed or a new library is introduced, and it can only vet that. Yes.
Hey, thanks for your talk. It seems like a lot of the things that you mentioned look like problems that are upstream in the open source ecosystem, whereas people who will potentially pick up these tools and start using them are commercial consumers of these upstream projects. Discovery of problems will then happen downstream, whereas remediation needs to happen potentially upstream. And so it seems to me that there's a nice chasm here that cannot be fixed or might not be fixed.
Very interesting. This is a chasm, and this is what makes this problem so difficult to solve. A security problem within an organization has control. Who has control of the open source ecosystem? No one, right? It's voluntary. Even VET. I can say that I will maintain VET for next 5 years, but my situation may change, right? VET may also become unmaintained. There is a project called OpenSSF, Open Source Security Foundation, who is trying to improve this. It's a slow process, but personally, I feel that if organization invest in the necessary tooling in choosing the right open source packages, which is maintained, which is supported by a decent community, and avoid single developer projects or avoid unmaintained project, then this problem can be controlled to a certain extent. But yes, it cannot be solved. It ultimately needs to be handled by some industry support. It's a more non-technical thing, more of industry support for critical software, building the specification required for the software producers like open source to publish security metadata, allowing consumers to make the necessary decisions.